solving equations using logs. So you've got your first question, so 3 to the power of x is equal to 11. So the first thing we need to do is effectively change or convert that sort of mathematical sentence into logs. So we'll say log 3 of 11 is equal to x. That's a nice and easy one. You can plug that straight in your calculator. So x will give you 2.183. Okay, happy days. Example 2, a little bit more complex, same kind of idea. We'll take logs of both sides first, okay? That's what we need to do, is convert that sort of mathematical sentence into logs. So we can say log 7 of 11 is equal to 5 minus 4x. And then obviously we get a number on this side if you wanted to do that straight away. Now, personally, what I would do is probably rearrange this to get x on its own first. So you'll have log 7 of 11, take away 5, because that's plus 5 at the moment, and then dividing that by minus 4, and that is equal to x. If you plug all that in your calculator, it'll be 0.942. So that's solved there. Okay, we're going to have a look at a slightly more complicated logarithm example. So this is writing this quite long question as a single logarithm, so that means it wants one expression at the end with everything in, okay? Now what we need to think about really is rely on your rules for logarithms, and obviously think about indices rules as well, because that's going to help us. So if we think about this first part and rewriting this, I'm going to have log a x to the power of 8, and then that's going to go to the power of a half, okay? I can swing that power up on top. Let's do the same thing here. We're going to have log a of 4x, I can't really do anything to that one, and then plus, I can sort out this one a little bit, so this one can be swung at the top there like a power, can't it? So I'll have log a 2 over x, and then to the power of 3, isn't it? Okay, let's think about then combining what we have. I'm going to sort this bit out first, okay? So I'm going to have log a, so 8 to the power of a half, so that's half, isn't it, of 8, which is going to give you x to the power of 4. Take away log a 4x, and then plus log a, and then let's sort this out a little bit here, okay? So you're thinking then about 8, because that's going to be 2 cubed there, over x cubed, which is there, okay? Getting rid of that bracket. Now we can combine, actually, what's here in one single logarithm, which I know will be a bit of a complicated looking one, but we can combine the two together. So when we've got something that's take away, what we can actually do is combine them to be division, can't we? We can put those together. So we'll get log a x to the power of 4, 8x to the power of 4 divided by this x cubed, and then we're dividing it by 4x, okay? So that's all becoming one expression, all combining them together. So what happens here is this one and this one have been added together. That means you times them, so that's where they've been put together. And then when you're combining those two and a takeaway, that means you are dividing, so we're dividing by this 4x, okay? So a bit like indices rules. And then sorting that out a little bit, obviously converting our numbers, etc. So you'll have 8 and 4. Now if we take a reciprocal, that's going to give us 32. Then we'll have x to the power of something on top. Now this is the important bit really on top, is 5. Okay, and then dividing it by x to the power of cubed, which is on the bottom. Now we're thinking about sorting that out again, really, making that a bit simpler. So you'll have log a. Now 32 is going to stay as it is. I can't do anything with that. However, I can sort out my x's, can't I? Think back to indices rules GCSE. 5 take away 3 is going to leave me with 2 of them. So my expression is log a 32x squared. So you're combining all your logarithms rules in one.